So, from our previous calculations, we just showed that our um, mu r squared times phi dot is equals to L. So we can see that phi dot is equals to L over mu r squared. Okay, that's pretty much algebra. So now, if we go and look at our equation that we found out before, so it was mu dot r double dot, and then it was negative d over d. Sorry, actually, I'll write it easier. Divergence of u in terms of r plus mu r dot phi dot squared. We can substitute this in here, so it's equals to negative divergence of u in terms of r plus mu r phi dot, which is the squared, which is the equals to L squared over mu squared r at the power of 4. So here simplifies this, so it comes up there. So we get negative divergence of u in terms of r plus L squared over mu r cubed. And as you can see, it is pretty neat that we can just substitute in there and we see directly how that affects it. But now, one thing that I want to think about is when we have, for example, planet moving around on this axis over here, then we have, on this rotation over here, and then we have, of course, let's say the sun at the center, doesn't matter. This planet does not actually go farther or closer in in an ideal circle. So it means that actually the acceleration given by this and the change in radius has to be equals to 0. Therefore, we have 0 equals to negative of this u of r, the values of u of r, plus L squared over mu, not mu times r cubed. So it means that these two things have to be equal to each other. So this has to be equals to this, as you can see very clearly. But one thing that you can think of this as is, do you see this part over here? We know that f is equals to negative the divergence of u, in this case in terms of r. So this means that this side over here has to be equals to a force. In this case, our centrifugal force. Because if we go back here, it means that this arrow that points towards the inside is the attraction force, or the gravitational force. The only thing that keeps it from going towards the center is the centrifugal force. And as you can see, f of g is then going to be equals to our negative divergence of u in terms of r, and our force centrifugal force then will be equals to L squared over mu r cubed. Now, let me write it better so you can see. L squared over mu r cubed. There we go. So now we know that this divergence of u in terms of r is also equals to d so equals to d over du, d of u over dr, and then so what b equals to, we said L squared over mu r cubed. So if we want to get rid of the du over dr, then we have to integrate both sides, and on the left we get u of r, and then on the right we get L squared over 2 mu r squared. As you can see, it is a pretty clever way to obtain our our force, um, our attraction force, which would be almost the gravitational force. So we can actually use this for uh, future things we will see. Because, uh, for example, in our example 8.1, we see that the U total is then going to be equals to this part over here minus the gravitational force. But that's going to be for example 8.1, which I think is pretty good to give a look at. It explains how pretty much comets and kind of orbit around planets or stars.